Welcome. Welcome to the podcast on counting principles. And this one's going to be on something called permutations. When you're calculating the number of ways that an event can happen, and the order is important, and that's important, it has a name, and it's called a permutation. So, for example, let's say a class has 16 students, and from this class you want to select a president, a vice president, a secretary, and a treasurer. Well, when you go to select the president, as the first person you're going to choose, you have actually 16 possibilities. When you go to select the vice president, since you've already selected someone, that actually only leaves you 15 possibilities. The secretary, then there's 14 possibilities, and then the treasurer, there's only 13. So when you select the president and then a vice president, we're using the multiplication principle, and then a secretary and then a treasurer. So we have 16 times 15 times 14 times 13. Let's actually evaluate that. So we have 16 times 15 times 14 times 13, and we get a total of 43,680. So that the number of ways is going to be equal to 43,680 ways. That's an example of a permutation. Another example, let's say you're playing a game of pool in which there's only 5 balls and they're numbered from 1 to 5. And how many ways can you hit the ball so that they go into the pocket? In this case, again, the order is important. And so if you hit the balls in the order 1, 2, 3, 4, 5, well, that's different than hitting them in the order 4, 3, 5, 2, 1. So the number of ways to sink the 5 balls, we're going to do kind of what we did before, is there are 5 ways to sink the first one, then there's only 4 ways to sink the next one, 3, and then 2, and then 1. And this is going to use the multiplication principle. So we multiply that, and you multiply that out, we're going to get 120 ways. Now when you calculate 5 times 4 times 3 times 2 times 1, that actually has there's another way of actually writing that. And you may already know this, but this also can be written as 5 factorial, or 5, and I'll write it for you. So on your notes, can you go ahead and calculate 6 factorial? Well, when you do that, that's going to be equal to 6 times 5 times 4 times 3 times 2 times 1. And since we already know that's 120, 6 times 120 is going to give me 720. And that's the idea. Now, you can also do this on your calculator. Let's clear that one. So if I want to evaluate 6 factorial on my calculator, I'm going to put in the number 6. Then I'm going to press the math key, and I'm going to cursor over to the PRB menu, which stands for probability. I'm then going to cursor down to number 4. You see that exclamation point or the factorial. I press enter again, and there's that 720. So that is a good thing to know how to do. Let's look at another example of a permutation. Let's say I have 10 different candy bars and I'm giving 1 each to my 5 best friends. How many ways could I hand out the candy bars? Well, I'll set up those 5 people that I'm going to hand them out. And then I have 10 for the first one, 9 for the second one, 8 ways for the second one, 7 ways for the next one, and 6 ways for the next one. So then you do that on your calculator and you figure that out. And let's clear that. So we're going to do 10 times 9 times 8 times 7 and times 6, and we get 30,240 ways. So we get 30,240 different ways I can pass out those candy bars. Now there's a way to write a permutation and a way to calculate it. And so the definition of a permutation, and you're going to want to write this down and probably stop the podcast so you can do that. What it says is to count the number of ways that R objects, that should be can and not cab, can be selected from a total of n objects. When the order is important, we are going to use the notation that looks like this. Number of ways, permutation, and taking R at so many R objects at a time. One way that I remembered is think of the NPR radio station. So for example, let's calculate 8 things taken 3 at a time when order is important. So I start with 8 and I do 3 numbers, 8 times 7 times 6, and you can do that on your calculator, and I'll let you do that and get that number. But let's do another one. Permutation of 4 things taken 4 at a time. So I start with 4 and then I do 4 numbers, 4 times 3 times 2 times 1. Remember from before, we can write that as 4 factorial, and 4 factorial is going to be equal to 24. Good thing to know, good thing to remember. So some examples we've seen so far. Remember the class 16 students, and you can select the president, vice president, secretary, and treasurer. That was the answer. Well, I'm going to write that as a permutation. 16 students taken 4 at a time, so that's 16 times 15 times 14 times 13, just what we did before. For the pool game, when I have 5 balls and I'm going to sink them, and I'm numbered 1 through 5, how many different ways? Well, that was the answer. And I can write that as a permutation. 5 things taken 5 at a time. And so again, that's 5 times 4 times 3 times 2 times 1. And again, that is also 5 factorial. Now for the following question, I want you to write it in 3 ways. I want you first to write it using that notation, that NPR notation. Write it as a product of numbers, and then actually write the answer. So the question is, the grocery store has 15 different kinds of candy bars. In how many ways can I pick my 3 favorite candy bars? Assuming your 3 favorite candy bars are among that 15. Could you go ahead, stop this podcast, and figure that out? Okay, it definitely will be a permutation, because for my 3 favorite candy bars, if I pick one or another or a third one, they're going to be different. So it's a permutation of 15 things taken 3 at a time. 15 times 14 times 13. I do the math, and there it is, 2,730 ways. Can you try this one? The grocery store has 10 varieties of candy bars. If I want to buy 4 candy bars, how many possibilities do I have? Give this one a try. This one is actually a little bit tricky, because the wording is really important. The question didn't say that the order was important, or that you couldn't buy 4 of the same kind of candy bars. So when we go to do this one, if I have 4 choices, I have 10 choices for the first candy bar, 10 choices for the second candy bar, 10 choices for that one, and 10 choices for that one. And so that's just equal to 10 to the 4th, or 10,000. So as you can see, the wording is really important in these questions in terms of what it means. Let's finish up with word arrangements. It's an important type of counting problem, and it involves rearrangements of letters and sometimes repeated elements. So what do I mean? Well, let's take the word math. How many ways can that be rearranged to create 4-letter arrangements, or 4-letter words, I guess, but they're not really words. So for example, I can take math, and then I can rearrange it, and I can do MA, maybe I'll switch that, and then maybe I'll do THAM. So in other words, how many different possibilities are there? Well, this is definitely going to be a permutation, because once I've chosen one letter, that leaves me only the 3 remaining letters, and then the next one, the next one, the next one. So if I have those 4 choices, there's going to be 4 for the first one, 3 for the second one, 2 for the next one, 1 for that one, and so that's 4 factorial in 24 different ways. But, and how many ways can the letters mom be arranged to create 3-letter arrangements? Well, in this case, there's only 3, because when I write mom this way, if I were to switch those 2 letters, it doesn't look any different. It's the same thing. And the same thing for this, and the same thing for this. Well, how do you figure that out? Well, what we're going to do is let's start by assuming that it is a permutation. So there's 3 times 2 times 1. But one of those letters is repeated twice. So I'm going to take this, which is equal to 3 factorial, and I'm going to divide it by that letter that's repeated twice. 2 factorial. Well, 3 factorial is 6. 2 factorial is 2. That's equal to 3, which is what I said it would be to begin with. So let's generalize that idea. We have another formula. And the idea is that, in general, to rearrange n letters where one letter is repeated k times, start by assuming it is a permutation. But if a letter is repeated k times, I'm going to divide by k factorial. So n things taken n at a time is the same thing as n factorial. And so what it really comes down to is n factorial over k factorial. Let me give you an example. I want to write that one down. How many ways can the letters in the word lily be arranged? Well, there's 1, 2, 3, 4, 5 different letters. I lost my sheet. There we go. There's 5 different letters. So I'm going to start with 5 factorial, but the letter L is repeated 1, 2, 3 times. So I have to divide by 3 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. And because this is all multiplied, what I can actually do is cancel out the 3 and the 2 and the 1, and I'm left with 5 times 4, which is 20 ways. I hope this was helpful. Make sure you have everything in your notes, and we'll practice some problems the next time we meet. Take care.